Hello learners, my name is Mr. Pochilola once again. We meet again for a lesson in physics in a topic called machines. The topic called machines is a topic in Form 3 physics. It's topic number 10 of physics in Form 3. Alright, so far we've covered or we've had 3 lessons in this topic, in which we have looked at the various aspects of machines. We have defined what a machine is and the terms associated with machines. We've also looked at the types of machines, such as distance or speed multipliers and force multipliers. Specifically, we've looked at types of machines such as levers, including the types of levers, namely the first order, second order, and third order levers. In lesson number 3, we looked at a type of machine which is called pulleys. So we defined what a pulley is. We also looked at the different types of pulleys, such as fixed pulleys, movable pulleys, and the block and tackle pulleys. And we looked at the associated mathematics and calculations. In today's lesson, we are going to continue by looking at another type of machine. Another type of machine which is called the inclined plane. The inclined plane, another type of machine. So far we've looked at the machines such as levers, the pulleys, and now we want to look at the third and last type of machine, which is called the inclined plane. What is the inclined plane? What is an inclined plane? When we say this machine is inclined plane, what is it? Do you have an idea what an inclined machine is? Can you try to define it? So what is an inclined plane? How did you define an inclined plane in Form 2? I'm asking you this because this is not a new topic. It's a continuation of a topic in Form 2, which is called power and machines. So what is an inclined plane? A plane, eh? Alright. In this lesson, we are going to define an inclined plane as follows. We'll define an inclined plane as a slope or ramp that enables us to raise heavy loads to a certain vertical height, either by pushing it or pulling it along the plane more easily than lifting them vertically to the same height. Alright, so let's take the definition again. An inclined plane is a slope. What is a slope? A slope is something that is slant, like this. It's a slanting flat surface. Alright, so this is called slope. It's called a slope. Another name for slope is ramp. Okay, so it enables us to raise heavy loads. Okay, for example, maybe a bag of cement. All right, you want to raise it here to this height. It's easier to simply push it along this plane until it gets there than to lift it through the height h by doing work against gravity. So it's easier to move it, to push it or pull the bag or whatever weight it is, load, through this ramp. This is called the ramp or slope. All right. So an inclined plane enables us to raise heavy loads, heavy weights. By the way, load in physics means weight. So it enables us to raise heavy weights to a certain height, vertical height here, measured from the ground level here, either by pushing or by pulling the load along a plane. All right, so we are saying it is easier for us to push or pull a heavy weight through this slope, the slope which is called inclined plane. All right, inclined plane, okay? So it's easier to push it or pull the load through this distance than lifting it against gravitational pull. So we are saying in the absence of this plane here, work could be very, very difficult to perform. It would be very difficult to perform work or lift this load through this height to a desired platform or height there without this plane. But with this plane, all we do is just push this up until you get to where you desire to bring your body or load. So that's how we define an inclined plane. What is an inclined plane? All right, it is a slope. A slope means that it is slanting. It's a slanting slope. It's a slanting plane, which is also called a ramp. So it's a slope which enables us to raise heavy weights or loads to a certain vertical height here, pushing or pulling them along the plane more easily than lifting it vertically to the same height. So lifting an object through a height is always hard, especially if the object is heavy. It's very heavy. Lifting it manually through this height, it is very difficult. But if you are to move the same body through a plane or a ramp, you can do it much, much easier. In everyday life, we have a number of examples of inclined plane. All right. Here, I am going to show you two examples of inclined plane. Can you think about some examples? All right, okay. But here we have two examples of inclined plane, namely the steps. The steps, all right. Sometimes when you are to reach a certain structure or a building which is at a higher level, with respect to the ground level, you have to climb the steps. So steps are an example of inclined plane, because if you look at this, there is an angle, or there is some kind of slope here as you're going up. All right. For example, at your school, at Marymount, you have steps, very long steps. As you walk from the Form 4 class, the new Form 4 classes, to the Form 3 classes, you have to climb up the steps. All right, because there is a height from the Form 4 classes to the Form 3 classes up there. There is a sharp height which you cannot climb in the absence of steps, these steps here. So you have to climb up the steps from the Form 4 classes. I'm referring to the steps at Marymount. There we have new blocks there. So to move from the new blocks going up to the other classrooms, you have to climb up steps. So steps, think about steps wherever they exist. They are an example of an inclined plane. But also, you can think of an inclined plane when you are loading a heavy object onto a truck. A truck is a big car. It's very high from the ground level. So lifting a body through this height onto the truck is very difficult. So all you have to do is arrange some wooden planks, all right, and then push the object you intend to load into the truck. So this again is an example of an inclined plane. It's an example of an inclined plane, all right? A wooden plank. So staircases, which are also known as steps, and the wooden planks, all right? They are all or both examples of inclined plane, all right? So all you have to do is push this through this ramp, through the plane there, and you get the body into the track there. It's easier that way than to lift it from the ground level up through a height onto the track. So two examples of staircase, rather inclined plane. So we have staircases or steps, and the wooden planks. These are wooden planks. All right. How does an inclined plane work? How an inclined plane work? How does it work? All right. Okay. Basically, in order to use an inclined plane to do work on a body, or to move a body through it, you shall need to apply a force. You shall need to apply a force on the load through the plane. Load, what should come to your mind when we're talking about load is we are looking at the weight of a body in newtons. Right. So you apply a force called the effort. So you apply a force called effort in order to move the load, to raise the load through a vertical height by pulling it along an inclined plane from, say, point A at the ground level to point B at the required height. What we are saying here is we have a body here which is intended to be brought to that height. Okay, so in the absence of this plane, it means the only available option is to lift it through this height by doing work against gravity. Remember, work against gravity, it's the mass of this body multiplied by the acceleration due to gravity, g, multiplied by the height. So in the absence of this plane, it is going to be difficult to move this same box to that height, because the only available option would be to simply lift it. So in order to do this same job easily, we shall need to lay a plane at an angle, this angle here. All right, so you push this body through this distance, which is the length of the plane. In so doing, you have made it reach a height h. So we are saying the effort E, this one here, is acted upon by pulling, this one is acted upon the load, so that concurrently, at the same time as you are moving this along the plane, it is also covering a height h. All right, so we are saying the effort E raises the load. It raises, as you're moving this, you are raising it actually through h. All right, it's going through, it's covering two distances. Here, the distance or the length of the plane, and also the vertical height is changing. All right, so we are saying the effort E raises the load L, the load, through a vertical height h by pulling it along the inclined plane from point A to point B, where it is required to be. Now, let us look at some notation that we use on the inclined plane. The first notation is the length of the plane. The length of the plane is simply the distance from A to B. We are referring to this distance here. This represents the length of the plane. It's represented by the letter L. Another important notation is the load. Load is simply the weight of the body which is being moved. As you are moving this body through the plane, there is also another force pulling it down. All right, so that force is called load, and it's basically the weight of the body, which is the gravitational force, mg. Great. Another important term to take note of is effort, which I mentioned earlier on. For this body to move, there is need for a force, all right? So that force can be either pushing it at the back here or pulling it in front of it so that it moves up through that direction. So we need a force which is called effort in order to move the body up. All right. Another important terminology or notation is the angle at which the inclined plane is arranged with respect to the ground, or in relation to the ground level, the horizontal. All right. So this angle has a name. Okay. It is called angle of inclination. All right. So the angle of inclination is the angle formed between the plane and the horizontal, the ground in this case. Alright, so it's called angle of inclination. The amount of effort which you have to apply shall depend largely on this angle as well. Alright, shall depend on the size of this angle. If this angle is very big, you need to exert a lot of force there, a lot of effort in order to move this. Alright, but if the angle is smaller, which you can make smaller by simply using a longer plane, alright, you use a longer plane, it means this angle is going to be smaller. What's going to happen is you shall need a smaller force to pull this up. Alright, so this angle is a very important parameter when we are talking about work done through a plane. Alright, inclined plane. Another terminology or notation is the vertical height. These are very important parts of the machine. The height, this one here, is also very important. Remember that when you are doing work on a plane, here, pushing it through the distance, right, concurrently it is covering a height, h, at the same time. Right, so that when it gets there, you can calculate the amount of energy that it has gained, the body has gained, by simply multiplying its mass by gravity by height. You remember that? All right. Okay, so these are some of the terminology or notations which you should get familiar with when you are dealing with inclined plane, which is a type of machine. All right, how do we calculate or work out the velocity ratio of an inclined plane? We've seen how we calculate velocity ratio of a lever, the velocity ratio of a pulley. What about the velocity ratio of an inclined plane? All right, the velocity ratio of an inclined plane is calculated or can be calculated using a very important formula such as this one here, velocity ratio. Velocity ratio is simply the distance moved by effort. We are referring to this distance here from A to B divided by the distance moved by the load, in this case the height. All right, so velocity ratio is the distance moved by the effort, just the distance in meters or centimeters, remembering that both of them are distances, so the units are going to cancel out, so that velocity ratio is a unitless quantity. So all you have to do, if you're given enough information in terms of distance through the plane, this one here, and the height, to find velocity ratio of the inclined plane, just divide the distances. Yeah, divide the distances. What you find is velocity ratio. So since distance is synonymous with length, so the distance from point A to point B is equal to the length of the plane. So if you are told the length of the plane and the height through which the body moves, then you can calculate velocity ratio again. So we are saying either length of the inclined plane divided by vertical height of the platform. All right, you can get velocity ratio. So using symbols that you see in the diagram here, you take the length here, the length of the plane, all right, divide by the height. Divide by the height. Be careful with units. Whatever units, they should be the same. Right? The units of length should be the same as the units of height. All right, if one of them is in centimeters, the other in meters, remember to change accordingly. All right, so that the units eventually will cancel out to give us a pure number, which is velocity ratio. Remember, velocity ratio is just a pure number. It does not have unit. It's unitless, we say. All right, so this is how you do calculate velocity ratio of an inclined plane. All you have to do is divide the distance moved by the effort by the distance moved by the load. The distance moved by the load is this height here. All right, or you take the length of the plane divided by the vertical height. It will give you the velocity ratio which you desire to work out. All right, I believe so far so good. We are moving together. If you have questions, please don't hesitate to forward your question in form of a voice note or a text to my number, so that I address the question either immediately or a little later after. All right. How do you work out the efficiency of an inclined plane? Inclined plane, eh? Remember, inclined plane. How do we work out its efficiency? Sometimes you'll be asked to calculate the efficiency of the inclined plane. How do you go about it? So the efficiency of an inclined plane is calculated in the following manner. All right. Efficiency, remember the definition of efficiency. It's a ratio of mechanical advantage to velocity ratio. But don't forget to multiply by 100%, because efficiency is expressed as a percentage. All right. Okay. So substituting or bringing in symbols, remember efficiency is represented by this symbol here, which looks like an N, but it's not an N. It's called nyo. Nyo. It's a Greek letter. It is chosen in physics to represent efficiency of a machine. All right, so efficiency is going to be equal to mechanical advantage in symbols, MA, divided by velocity ratio, VR, multiplied by 100%. Okay, so whatever values of mechanical advantage and the velocity ratio, you substitute here and multiply by 100%. It is going to give you the efficiency of that inclined plane. Remember that a machine is not 100% efficient or perfect because of other issues such as frictional force, for example, or lifting, a machine lifting parts which are not necessary or which are not useful, all right, in converting input energy to output energy. So how do we improve the efficiency of an inclined plane? All right, how do we improve the efficiency and the mechanical advantage of an inclined plane? Eh? All right, so there are three ways that you can put in place in order to improve the efficiency. Improving efficiency here simply means increasing the amount of work output, because if the work output is high, then it means that the efficiency is also going to be high. Remember, efficiency is also defined as work output divided by work input, expressed as a percent. So if we increase the amount of work output, then we are sure to improve on the efficiency of the machine. So there are three things that we can do in order to increase the efficiency of an inclined plane. Namely, we can use rollers alongside the inclined plane to reduce the size of the effort applied. So when you use rollers, the amount of force that you apply becomes less. Therefore, its efficiency is going to be higher. Remember, less effort means less work done against friction. So reducing friction means that overcoming friction means that the amount of work output is going to be higher. Another way to increase the efficiency of a mechanical advantage and the mechanical advantage of an inclined plane is to use a longer plane to reduce the angle of inclination. Remember, I mentioned that the size of the angle of inclination will determine the amount of effort applied. So, in order to reduce the size of effort, the size of effort applied, all you have to do is use a longer plane. So this is done in order to reduce the size of the effort applied. Another way to improve the efficiency of a machine is to reduce friction. How do you do that? By simply polishing the inclined plane, the surface of the inclined plane. You polish it, all right? You can use sandpaper, for example, to polish it so that the amount of friction is reduced. Remember that friction causes heating, so that heat is radiated to the surroundings. As a result of that, the amount of work output is reduced, all right? So very important to note that, okay? So these are the ways. They may ask you in your exam to say, state any 2 ways. Make sure you know all of them so that when they ask you for 2, you should be able to say without problems at all. All right. So before we go, I want you to find time to do these questions, to answer these questions in your exercise book. Once again, what you do is simply to answer the questions in your book, in your exercise book, and you take a good picture of it and then send it to me. But also don't forget to keep the exercises, the work that you have done in the book, so that when you are back to school, I should be able to call for them to mark them for you in that book. So don't just write scantily and sketchily on a piece of paper. No, make sure you find a right book, write all the questions and find the answers neatly, and then you can bring the book over to school so that I can mark for you. And in the absence of that, for now, for the time being, what you do is just take a picture of the work and send it to me. I'll be able to respond, okay, after looking at your work. Mind you that you are many of you, over 200 of you online, okay? So if you see that I'm delaying in responding to your exercise, don't worry, I'll still find time to respond. All right, so an effort of 50 newtons is used to hurl. To hurl is to pull 300 newtons box along an inclined plane which rises vertically 1 meter for every 8 meter distance along the plane. So here, what information do we have? So this is the effort, this is a load. So this is load, right? This 1 meter here is referring to the height, the vertical height. and the length of the plane is given as 8 meters. So what do? We should use this information to find the velocity ratio. Remember, velocity ratio of the machine is simply the length of the plane divided by the height of the plane. So in this case, the length is 8 meters and the height is 1 meter. So this, when divided, will give you velocity ratio. And also, you are asked to work out the mechanical advantage. Find mechanical advantage. So mechanical advantage, by definition, remember, is simply the load divided by effort. So the load is 300 newtons. The effort is 50 newtons. All right? Right? And then calculate efficiency. Remember, efficiency is equal to mechanical advantage of the inclined plane divided by velocity ratio multiplied by 100%. That will give you what you want. Okay. Moving forward, having done that, there is this which you have to explain based on your results. State the factors in this arrangement, in this inclined plane, that make efficiency less than 100. Why did we say that? We always say that no machine is perfect. No machine is 100% efficient. Why? So explain that. We have explained this a lot. I want you to say it again. All right. Number 2, a roller of mass 200 kgs is pulled along an inclined plane by a force of 150 newtons. As shown here, calculate the mechanical advantage. Mechanical advantage is, here you have to be careful. You are not told the load here. It's hidden. But you can get it from mass. All you have to do is change the mass to newtons. What do? You multiply by 10, multiplied by 10, multiplied by 10 newtons per kilogram. It will give you load. The effort is given here. So to find mechanical advantage, first change the kilograms to newtons, all right, by multiplying by 10, and then divide that by the effort, which is 1,500. So this will give you mechanical advantage when divided up. All right. Then velocity ratio, remember velocity ratio is simply the mechanical advantage of the inclined plane divided by velocity ratio is simply the length of the plane divided by the height. So the length here you are told is 5 meters, the height you are told is 3 meters. So when you divide these two, you shall find the velocity ratio of this machine. So using the answer you get in A and the answer you get in B, you can calculate efficiency by simply using the formula. Efficiency is equal to mechanical advantage over velocity ratio multiplied by 100%. So this is very easy, straightforward to do. Please get hold of papers. I have plenty of papers which I can share with you. Let me know if you have time so that I can share with you these papers. You should be checking from papers, money papers, mock papers from different schools, and try to answer these questions if they are here, there. It is good to practice than simply to pretend that everything is all right when it's not. Practice and more practice is very important for you to make it in education, in your studies. Great. Number 3, we are told that a student wanted to put 10 boxes of salt at the top of the platform using an inclined plane shown. So we have a plane here So this is a box of sorts. So the student wants to put 10 of these here on the platform. All right, 10 of them. Okay, each has a mass, rather a load of 40 newtons. So if there are 10 of them, it means you have a lot, you have more load or weight. Okay, so as shown in the diagram, if the resistance due to friction is 10 newtons, all right, so as this is being dragged up, there's also another force dragging it backwards, which we call friction. So remember, the use of work done is the work done by the effort minus the work done by the friction. Right? Don't ignore that. Don't ignore that. So the work done in moving, calculate the work done in moving 10 boxes. So we are looking at 10 boxes. All right? Work done. Okay? Work done is equal to effort times distance. Don't forget that. The effort the effort here is effort given. No, the effort is not given, but you can still work this out without the effort. Okay. All you have to do is solve you start from somewhere to solve for effort. You should be able to find the effort, how much effort is applied here. It's hidden deliberately for you to find that. All right. And using the information, you also have to calculate the efficiency of this inclined plane. What is the efficiency of the inclined plane? All right. And then calculate the effort required to raise one box to the platform. So I look forward to getting your work done neatly in a book, and take a good picture. Please, when taking pictures, make sure you're taking pictures in full light. Some of you are taking pictures in the dim light, and I'm struggling I'm struggling to see your work because it looks so dim. Okay. All right, so that's what we had for today. Thank you very much for being there to learn. I don't take that for granted. It is for your good. It is also for my own good as a teacher, because when you do well in physics, in Msce exams or whatever exams you are taking, it gives me so much joy. So once again, thank you very much. This brings us to the end of the topic called machines. A topic called machines. So we meet again in our next topic, which is going to be topic number 11. In topic number 11, we are going to be looking at electricity. So I look forward to seeing you again. For now, it's a big bye-bye to you.